This is a simple 3D printed robotic hand called a gripper. It's controlled by a servo motor that can move between 0 and 180 degrees. Today we'll be training a visual AI agent to make the hand go from open to closed. The way that we'll be doing this is using reinforcement learning, or RL for short. Reinforcement learning is learning through trial and error. An agent, which could be anything from a video game character to a self-driving car, takes actions inside an environment. As it does good things or bad things, it receives positive or negative rewards. Over time, it learns to adjust its behavior to maximize the amount of positive rewards that it receives. In this case, our agent is the gripper, and the environment is the real world. The actions the agent can take are to increase or decrease the angle of the gripper by 10 degrees. But there's a catch. The only thing that the AI agent can observe from the environment is the image of itself that it can see through this webcam. It has no knowledge of the position of its motor. This is why we call it a visual agent. It'd be like if someone asked you to close your hand, but you couldn't feel your hand, you could only see it. Before we can start the RL training, we're going to need a way to automatically tell whether or not the gripper is open or closed. To do this, we can use an image classification model. An image classification model simply learns how to take an image and place it into an arbitrary class. For example, classifying images as pictures of dogs or cats. In this case, we only have two classes, closed and not closed. We can be a little bit generous and say that the gripper is closed as long as it's below 15 degrees. To train our image classification model, we can simply collect photos of the gripper at each of the 180 angles it can be at. We can then label all the photos where it's under 15 degrees as closed, and all the other photos where it's over 15 degrees as not closed. Then we can use TensorFlow, which is a popular machine learning library, to define our image classification network as a convolutional neural network, or CNN for short. I won't go too much into the details here, but you can think of a neural network as the brain of an AI, roughly similar to how human brains are made up of connected neurons. A CNN is just a special type of neural network that's good at handling images. Now we can train our CNN by showing it pictures of the gripper at different angles, along with labels for whether or not a certain picture is closed or not closed. Over time, the CNN will learn to accurately predict what closed and not closed pictures look like. After training a simple CNN architecture using TensorFlow, we can see that it learns to predict when the gripper is open and closed with close to perfect accuracy. We can test our image classification model in real time and see that it is accurately able to identify when the gripper is closed and not closed. Now that we have a way to automatically tell whether or not the gripper is opened or closed, we can finally get to the reinforcement learning training. The setup of the RL training will be as follows. It will run in episodes, where every episode, the gripper will start at 90 degrees. The AI will have two possible actions, either to open the gripper by 10 degrees or close the gripper by 10 degrees. Each time the AI takes an action, we call that a step. And the AI has a maximum of 50 steps or 50 moves to try to close the gripper each episode. So the AI will take multiple actions in each episode. If it's not able to close the gripper within 50 steps, then the episode restarts. If it is able to close the gripper, our previously trained image classification model will tell us this and the episode is stopped. The agent would then be given a reward of +10 for successfully completing the episode. After the agent receives the reward for completing the episode, it tries to remember the actions it took to receive that reward and to replicate them so that it can receive that reward again. By doing this, it learns to close the gripper. We give the agent 50 steps to reach the goal, but in reality, it can do it in only 8. So it has the potential to learn an inefficient trajectory. One way we can incentivize the agent to learn the optimal trajectory to the goal is to give it a small negative reward of -1 each time it takes an action. To understand why this works, consider 2 trajectories an agent could take to reach the goal, one taking 20 steps and another taking 10 steps. In the trajectory that takes 20 steps, it would receive that -1 reward for each step, or -20, plus the positive reward of +10 for reaching the goal, leading to a cumulative reward of -10. In the trajectory taking 10 steps, it would receive a reward of -10, plus the reward for reaching the goal, to receive a cumulative reward of 0, which is greater than the -10 reward it would receive for the longer trajectory. The agent always wants to maximize its cumulative reward, so it would learn to follow the trajectory that takes the shortest path. The reinforcement learning algorithm the agent will use to learn the shortest trajectory is called Proximal Policy Optimization, or PPO for short. The details of PPO are beyond the scope of this video, but basically just understand that it's a state-of-the-art algorithm for learning from experience. Finally, we can get into training. We can see that after about 1 hour of training and 4,000 total training steps, it masters the ability to close itself from purely visual observations. This was a pretty simple task, but this same framework can be used to teach whole robots to manipulate themselves or other objects, and I'll be showing more of that in future videos. Thanks for watching, and I hope you enjoyed this video. For more info, check out nums.ai.